Hi there, welcome back. Well, time for some alignment, and the first one I'm going to do is the AM-IF alignment. I mentioned in the last video that this thing has two IFs, 460 kilohertz and 2 megahertz. So we'll start with the 460 and go from there. Now the first stage of alignment is done on this board, the IF board, and as you can see there are quite a few of those filters there. There's one down there, one there, two there, and one there. And this is the first stage of the alignment. So what exactly are we doing here? Well, first of all, they tell us to set the bandwidth on, or rather the width of the IF on narrow, small, and use a modulation frequency of lower than 1 kilohertz. In other words, whatever tone you put through there, we'll make it 600 hertz. That's good enough to listen to, if we have to listen to it. And then it says that the IF frequency is 460 kilohertz. It says 452 for Benelux Ausführung. For some reason, they use a different IF frequency. This one's 460. And then they tell us which filters we're going to adjust. We're going to adjust filter 21, filter 20, filter 19 and 18. Those are the two side by side that I showed you. Then filter 17 and 15. And for that, you've got to select K3 or shortwave 3 to 10, whereas here you had medium wave selected. And what else? And then there's the filter 16 with medium wave selected, and that goes somewhere else. And they also tell you where to put the signal in. Now, they do say Wobbler ausgangen. So effectively, they're telling you that the wobulator output, in other words, the generator output, should go to these points. And they tell you which points. To adjust filter 21, they tell you to connect the signal to point 3 of filter 20, so the previous filter. And this one, filter 20, they say 0.3 of filter 19, and so on. So they're wanting you to adjust these from sort of the end backwards, one filter at a time. And we can do that. But I decided to try something. I wanted to see, oh, and just while we're at it, they tell you to connect it to a test point near collector of T19. And then they tell you which ones to adjust, 1, 2, 3, 4, 7, and 6. Now these are quite clear on the other drawing, on the schematic. On the actual image of the board, you can see, it's not easy, but you can see that it says there, filter 21, ZF21, and that's adjustment point 1. There's T19, the transistor they tell us about, and we've got to find the collector of that and connect to the collector of that. Then there's filter 20, ZFXX, which is adjustment point 2. Then we have filter 19 and 18 and filter 17. So all these from 17 to 21, are on this board. There are a couple then that go off this board, but we'll get to that in a minute. They do tell us something else. They tell us to adjust for maximum and for symmetry. Now, I wanted to know what signals I'd be getting out of here anyway. What signal will I be getting at the collector of transistor 19? If I feed a carrier in it, do I need to modulate it? It's not that clear. They do say that you modulate it with a lower than 1000 hertz signal, but is that what we are seeing at the collector? So I decided to try it out. So what I've done is I'm feeding a 460 kilohertz signal at the lowest level that I can get on this signal generator, which is 1.4 millivolts RMS. I'm feeding it as usual through this adjustable attenuator. I can get 18, 12, 6, or the sum of any of those attenuation. And I'm feeding it into there, which is the input to this board, which is on filter 17, which is effectively the start of this filter chain down here. So it's going in here. So it's going in here and it's going to go through filter 17, which is the start of that chain of adjustments. And this is what I get on the scope. Now, if I take my adjustable attenuator and I remove 12 dB, or add 12 dB, I beg your pardon, this is in fact the representation of the carrier level, because I've got the carrier going in with no modulation. Now, because they tell us to adjust for symmetry, I had an idea. As you can see here, they say you adjust 5, V for symmetry, 7 for maximum and symmetry, and so on. So this has obviously got to be a curve, not a single frequency wave. In other words, we need a wobulator effect. In other words, we need a sweep. So let's set that up. So I set up a sweep, and the sweep has a linear sweep, start frequency at 448. Now that is exactly 12 kilohertz below the IF frequency that I want, the center. Stop at 472, which is 12 kilohertz above what I want, and I'm doing it in 12 milliseconds. And you'll see why in a second. Again, the same level signal, that's the sweep, okay? Now I've got the scope measuring at the output of that little RF detector that they give us there, just so that I can get a rectified RF. And let's look at the scope and see what we've got. Now this is where things get kind of interesting. If you recall, I had the sweep time to 12 milliseconds. What I've got coming into channel 2 of the scope is the trigger output signal from the signal generator. And what that means is that every time a sweep starts, this thing gives me the start of a square wave. And when it ends, the entire square wave is represented. If I turn the time base down, I've got it now at 2 milliseconds per division. What you're seeing here is effectively 2 full waves. Okay? If I set it at 1 millisecond per division, I am seeing the entire square wave, one entire period of the square wave on the scope. And the reason for this is that this is 12 milliseconds per division, or rather 1 millisecond per division, but I've got 12 divisions here, 6 on either side of the center. Okay? So this way I get the entire wave across here. And this means that the sweep is starting here at 448 kilohertz, and it goes across, and it ends here at 472, and then it starts there again. And I know then that the middle, because it's a linear sweep, the middle will be exactly 460 kilohertz. And what I want to do now is see what result I get from that, basically that set of filters. Okay? And because I've got channel 1 connected to the output of that RF detector, which is connected in turn to the collector of that transistor as they indicate, this is what we get. I've got the scope triggering on channel 2, obviously. This is what we get. At 460 kilohertz, obviously this is not what we get first time round. You get something like this, right? But if you adjust the amplitude and you bring that down, because you're only interested in the section above 0, right? That's what you're getting. And that means that at 460 kilohertz, it's not quite on a peak, but we can see sort of a double hump. This is the width of the IF. And because I want this to be uniform, I want a nice bell curve with a little bit of a flat section at the top, I can now start adjusting those coils and see if I can't improve the height. And the height will tell me that I'm improving the sensitivity, and the steepness of the sides will improve the selectivity, and the width of the top will give me the width of the bandwidth that I'm allowing through. I don't want this thing to be an absolute spike, because that means that no audio bandwidth will be coming through clearly. I want this to have a sort of a flat top. So I'm going to start at the bottom and see what we can achieve. See if we can't improve that. I'm starting at the bottom on filter 21. Filter 21, here goes. No. Oh. That sort of starts turning down, so I'm going to leave it there. I'll go to the next one. That rolls it over, so I'm going to leave it there. Go to the next one. Whoa! See, that is making it narrower, but it's making it more sensitive, and I like that. For AM, I want sensitivity. Now let me try the other one. Nope. There. Let me try the last one. The last one, I'm not getting anything here. I think I have to inject before that. Let me go down again and try improve that somewhat. See, that's pretty steep. That's a very nice curve, and it's right in the middle there. Let's see if I can't improve it a bit more. No. I'm alternating between basically all of them, seeing what each one does, and trying to improve it. No. There it is. Slap on 460, I think. It moved a little bit. There. And I think that is quite an improvement. I think. What have I done? I've actually made this narrower. So I've made it less hi-fi, but we're not looking for hi-fi sound on AM anyway. And I've made it a lot more sensitive. And because this is now steeper, I've made it more selective. Now remember, this is only the 460 kilohertz, and it's not even the whole thing, because there are still a few others that I need to do. I need to put this on, I need to do the next three. This basically was 1, 2, 3, 4. 4 filters that I've adjusted. 1, 2, 3, 4. Actually 5. Now I need to go back in the circuit and do the same thing and put it where they tell me to. And I'll keep adjusting this and keep looking at this and see what the result is. So what have we actually achieved? Well, we have been feeding a signal into here. We've tuned that IF transformer. We've tuned those two. We've tuned that one. And we've tuned that one, because we are detecting the signal over here. Now, this has all been at 460 kilohertz, because that is the IF that we get coming in here. Now they tell us to go further back because there are a few more filters we need to tune. And this is where things get a little bit more complicated. For example, here they tell us to tune filters 17 and 15, we need to press K3 or shortwave 3 to 10, and we need to feed the signal on capacitor 223, and then we're supposed to peak those points 5 and 7. Now this is where it got a bit confusing for me. You see, 223 is actually before the conversion from 2 kilohertz IF to 460. Let me show you. That there is capacitor 223. And that there is still on the 2 kilohertz IF. It's on that bottom board down there. So I tried feeding a 460 kilohertz signal on there and got absolutely nothing. Then I remembered where I was and I fed 2 kilohertz and suddenly things started to make sense. But there's something else I want to show you first. Somebody asked what it means to lightly couple. And I gave an answer in the comments that it was capacitively coupling to a particular point. I tried without this, but this seems to work fine, and I prefer to do this because it's less intrusive on the circuit. What I've got there, the yellow wire is soldered to the collector of T19, and the orange wire goes to that RF detector. In this case, I'm just reading the signal at the input of that. I'm not actually rectifying it because you can see the scope is actually at the beginning of it. But the coupling comes through the winding of those two wires. So effectively, there's no touching. It's just the capacitive coupling between the two. And the result is that signal on the scope. So as you can see, the signal gets through pretty well. In fact, it probably doesn't have to be coupled as much as that. And the less you couple it, the less intrusive it is on the circuit, the less loading you provide to the circuit. But that's what I've got coupled there now. So what we're seeing here is a signal going into the front end, the part that I measured the slope to, and this is coming out at the collector of T19. So that's where it's going in there. Basically, it's coming into that section, which is the same as the description we had for the first few filters we had to tune. Now we need to go a bit further back, and I'll go to that point down there and I'll show you what we get on the scope. So I'm effectively getting nothing there, but if I turn this to 2 megahertz, so now I'm sending 2 megahertz across, and I have to select K3, or rather shortwave 3 to 10. That's what we get. We've got our 460 kilohertz carrier wave there again at the same spot, which is that sniffing it at the collector of T19. So let's see what we need to tune on there. It tells us to tune 5 and 7 for symmetry and max. I'm just going to tune for max and see what we get. Now 5 is that first one we did. Well, we didn't really tune that one. That's at the entrance to that board, the IF board. And of course what they're doing is taking the signal further back and getting us to tune it, to tune that particular one, which we hadn't done so far. So let's do that. So I'm going to tune that one there. So I'm going to peak that. That seems to be about it. It's a lot more touchy because we're dealing with 2 megahertz rather than 460, but I think that one's peaked. Now we need to peak, what is it, 7? Let's see what that is. C7 is here. And that is inside there. So that's what I'm going to adjust now. There's my peak. 7 is done, and that's all on the 2 megahertz line. Right, one more step completed. Now they say you feed the signal to the base of T12 and you're adjusting filter 16 with medium wave pressed, and you're supposed to adjust 6 for maximum and symmetry. So medium wave pressed. Right, medium wave pressed. Now T12 is actually on that upper board over there. And it's actually way in there. No, not on that side. It's in here somewhere. I'll show you on the drawing. It's way in there and it's not easy to get to, but I'll show you. There's T12. And the base of T12 is that line over there. And I've found the best way to get to it is on resistor 404 on that end. Feed a signal into there and see what we get out. So let's try that. Now this point is very finicky. I'm doing it with a spiked probe, which is not screened, so a bit of noise gets in there. Not easy to get it. There we go. And the one I need to adjust is the one just below it. So, and I'm back to 460 kilohertz. Wrong way. There's my peak. Done. Okay, good. And that concludes the alignment of the so-called 460 IF. But as we saw, one of these was actually at 2 megahertz, which one of two things. Either they got it wrong or I've misunderstood. But what I do know is when I try and put 460 on there, I got nothing. So there's a little bit more to do. We're nearly there. And that is this section. 2 megahertz. And they tell us where to put this in there. The first one is we need to feed back to C223, which is where we've been before. And let's see, what do I adjust? I've got to adjust 0.8 to a maximum. Where is that? Well, at least it seems to be fairly accessible. There's 8 over there. And that seems to be that top guy over there, which seems to be all painted in. Not a good sign. And I made a decision. These changes I made here were fairly accurate. Hardly any adjustment was made. I am not going to break that seal. That one is staying well enough alone. This thing is giving me a very, very good and accurate passband. I'm not going to tempt fate. Let's see what else they wanted to do. They tell us to feed the signal into the base of T5. And we adjust points 9, 10, 11, and 12 for maximum. And that, of course, is with 2 megahertz signal going in. Now there's T5. So I'll just have to see where to pick it up. I need the base of T5. That there seems to be the closest point for that connection. They do tell us we can connect it to Z2 over there, but I don't want to mess with that. So let's see what we get. And I need to adjust. What do they say? 9, 10, 11, and 12. Okay, so here's 9. Here's 10. Here's 11 and here's 12. Now these two are the ones inside that can. So let's have a look at them. So those two on the bottom right, and 11 and 12 are these two over here. So let's see if it makes any difference. Okay, let me start with the lowest one. No, that was perfectly peaked. Do one of the others? Let's see. That was also perfectly peaked. You know what? I'm doing nothing here. Which means, let me try the other two. Just for thoroughness. Got a little bit out of that one, I think. And finally, maybe just a little bit out of that one. So our signal has peaked. We are there. We've done the full IF alignment for the AM. And that means we've done the 460 and the 2 megahertz alignment. And that means that this thing should be as optimum as can be. So before we go on to any further step, let's see if we can detect any improvement. Medium wave.
Para manifestarse contra la masificación turística. Apoyo a minar.
Putting it on broad and narrow. There's broad, narrow. This is amazing.
Muchas de nosotras hemos...
de serie, no eran las escenas de acción que...
This is amazing. Long wave.
Il a déclaré sur la chaîne ABC une guerre de communication rondement menée avant l'apparition du livre, selon Gérald Goldy.
Afternoon, don't get much on long wave anyway. That's the beacon. Let's try these guys down here. Looks like everything's in the 31 meter band, so I'll put the band up. Let's try that one. Yeah, that's it.
Dio está stupito.
国家债务
Yes, non fuori. Le confusi l'americamento ieri.
能力恢复精神。
كروبية كويس وتتعافي كاسد كالهيمانوت بتبستيانوس كالو
Apa officier ikaw, wala ka wala needing si undo man. Puro memorial atas.
Pessoas aumentou e o governo está para apoiar um milhão de pessoas, segundo revelou o vasto.
That's on about 17.7 megahertz. So, bloody hell. Again, probably imagining it, but this thing sounds like it's livelier, even livelier than it was before. And I think the most obvious was actually on the medium wave. This is amazing. Enough said. I am extremely happy with that result. I know I keep saying this, but I really am. And I now have satisfactorily completed, to my satisfaction anyway, the IF alignment for the entire spread of the AM. I have not touched the FM, obviously. There's one last thing I want to do, and that is I want to check my 7 megahertz reference again, see if it's changed at all. 7 megahertz modulation, give it some amplitude. That would help. There we go. Looks like it's on the same spot. You go up here. Yeah, it's practically on the same spot. Okay. In summary, AM IF alignment is complete. I think there's been a slight improvement. I don't think it was dramatic because when I was speaking this thing, it wasn't. I did make that curve a bit steeper, so maybe it improved selectivity a little bit, maybe sensitivity a bit too. But you know, when you get to that level of detail, I don't think it's made much difference. I think nobody tampered with this before, which means that it had held its values pretty well. The next thing I want to tackle, which I'll do in the next video, is I want to do the RF alignment. I want to make these scales accurate, and it is especially important for me on the shortwave bands where you have the band spread. Now it's pretty, especially things like the amateur band where you're supposed to get 40 meters on there, and you find that instead of there, it's slightly to the right. Not that I'm going to use this for much referencing, but I do want to get it accurate, and I think this radio deserves it. And so that'll be next. So I hope once again that you've enjoyed it. If you have, please click like, share, subscribe, and all that jazz, and I'll see you back soon. Thanks for watching. Bye for now. Stay safe.